Hi everyone, this is Stefano from SottoZen channel. Welcome to a new tutorial, and this one is based on a request. Squid Montage asked about a groundbreaking tutorial. So I prepared this for you, and I will show you few tricks about a different approach on the use of the self-fracturing add-on that we have in Blender. There's a lot to talk about, so let's get started. Okay, I will start this by adding a simple cube that it will be my ground object. So let's scale down on the z-axis, something like this, and scale once again, this time avoiding the z-axis, only on the x and y axis, something maybe 6 times. Let's say that this will be our ground floor object that we want to destroy and make it crumble down, starting from the center area later. So I want to apply the scale, first of all, in order to reset the scale value to 1, 1, 1. And now that I have this, I can probably name this ground entire object. I will add a new collection that I will name active fractured object. And now you probably know that in Blender we have the self-fracture add-on. That's a very powerful tool that will help us in the shattering process, but I will show you something that's very important to know in order to get the best result from this kind of process. So the first thing I want to do is to increase this overall source limit to 500. That's quite a large number. And the noise factor, I also want to make it near to 1, something like 0.8. This will add irregularity and some randomness to the chunks that will be created during the Boolean process. So what happens if we run this add-on on this very basic and simple cube that we have on our scene? Let's see, let's press OK. And you directly see that even if we have 500 as max source limit, we only get 5 or 6 big chunks. Let me unhide again my entire object. So the first thing to know is that we need some resolution on our object in order to get more chunks from the cell fracturing process. So if you see that I entered edit mode, added some loop cuts, and now if I run the self-fracturing add-on with the same value from before, once again, you directly see that we get more of these shattered pieces. So let's try if we can get even more. And I can do this selecting all and subdividing the mesh a few times. So now I probably expect to have a lot more chunks after the shattering process. And in fact, I got more pieces. But if I select them all, and let me here enable the statistics option here, you see that if I select all these objects, they are less than the half of these 500. Even if you start to increase even more, we can try. I will show you in one moment. I subdivide more my geometry and try this again. You see that the only things that increase is the calculation time, probably because of the complexity of the Boolean operation that's based on this process. What I get is only more calculation time, but I can see here that it's still less than 200, maybe 10 pieces more from the level before. So in order to get a lot of shattered pieces, we have in this self-fracturing panel some other option like this recursion panel here. You can increase the recursion levels of fracturing. Also, you have this annotation pencil option that allow you to draw with your pencil tool and drive somehow the direction or the area where you want more pieces or less. But in my experience, at least, I have to say it's quite difficult to get a nice and creative result and have 100% of control of how the shattering process is happening. So what I'm going to show you is my own way, and I will show in this tutorial how I used to approach to the fracturing process when I need some detailed ground-breaking effect. So I don't want to have a mesh so dense in vertices as a starting point, so I will delete this and create a new one. So scale on the z-axis 0.2 and scale holding the shift and z to avoid the z-axis 5 times, and this is the exact object that I used before. Apply the scale, enter edit mode. I will add few loop cuts. I increase the resolution of my object because I want to have, let me move this object back again into this collection that we can call ground entire. Okay, so let's now run the self-fracturing add-on. And I want to move all this to the active fractured object. So I have separated. In this collection, I have the entire object that I want to hide now. And now I have these chunks that is a good starting point, but it's far from the result that I want to get. So before we continue, I want to show you another important part of the self-fracturing process, and that's regarding the result that we get. If I enter edit mode on this object, now with all my vertices selected, I press M, and from the merge menu, I want to choose by distance. And you see that Blender welded 22 vertices. This means that all these meshes that are created from the self-fracturing process contains a lot of unnecessary vertices. Let me undo this. You can see that if I try to bevel this, I get really weird result. Okay, this is a messed up mesh. If I merge by distance the unnecessary vertices, and now I try once again to bevel this, you see that it's now working better. Of course, the topology is not the best one to do this, but I can now select this edge loop, and probably I will be able to bevel this in a good way. So if later I will want to add the bevel modifier to all the chunks, I will be able to. Otherwise, it will be not possible. So let me go back here. So you have to select them all and enter edit mode for all of them, and pressing A, be sure to select all the vertices, and then press M and clean them up, choosing merge by distance. And you see more than 500 vertices was welded together by Blender. So this means that now you are dealing with a more clean and simple object, and also your overall scene will use less memory because we are getting rid of all those unnecessary vertices. So now the next step is to add detail where we need. I said before that I will try to make this ground object crumble down starting from the center area. So what I will do is to select this big chunk here and run the cell fracture once again. And in this way, I'm increasing the resolution of this area. Now, what I have to do is to be sure to select, you can see by the outline, the entire object and get rid of it. So let's do the same for this big guy here. Select the entire object and get rid of this. I don't like this shape here, that's quite long, so cell fracture again. And you see that it's very fast, the process, because each time it's working only on one piece. And I have total freedom of controlling the area where I need more pieces. And of course, it's a little bit time consuming, but it's nothing complicated, and it's also quite funny. So let's say this one. Okay, remember what I showed to you before, all these new pieces are all messed up. So after few levels of breaking down these pieces, I want to select them all, enter edit mode and press M and merge by distance. And you see here almost 2000 vertices welded together. So let's continue our process. And by the way, I add the cell fracture add-on is down here under the quick effects cell fracture, but pressing the right click, I set a shortcut, in this case F9. So because I know that in this kind of process I have many times to go here, back and forward. So pressing F9, I get this quick access to my panel, and I just have to click OK to run the add-on. So let's continue the shattering process. Maybe this one. Always remember to get rid of the entire overlapping mesh, otherwise later in the simulation process you will get some explosion because of the overlapping and colliding objects. And you see with this process I can really go deeper in the resolution. It's just a matter of repeating the process, and it's quite fast and easy to do. And be sure to always control the see the contour, the highlighted contour of the entire object that you have to delete. And also to delete the object, you can press X and then delete, or you can just press cancel, and that's faster. Okay, you get the idea. I will continue this process and I speed up the video. You can also shift select to different objects around the self-fracturing process, and the add-on will shatter them one after the other. This I really just find out doing now. So if you, like me, didn't know about this, I just found out this now. So now I probably can select this and then shift select this one and shift select this one, and you see, and it seems to work. Only always remember to delete the entire object, but you see this overlapping gray area. That something is not good. This means that something is overlapping. The only problem is that this process for me is somehow quite addictive. I mean, when you start, you always want to make another one. Another one is like a funny game that you cannot stop. So let's use this method with moderation. Don't be addicted of shattering objects like me. You see, I'm talking to you, but I'm continuing breaking pieces. Because you say, hey, also this one. Why not? Also this one. Okay, this is the last one, I promise. Okay, so I ended with this nice pattern. You can see that I was able to focus on this area more than on this outer area, and you can use this method in whatever need you have for your scene. You can go across one line or follow a path. It's only a matter of patience and repeating the same process over and over. Okay, so now that we have, let me see how many, we have 910 shutters on our scene. Let's enter edit mode for all of them. Be sure pressing A to select all the vertices. Press M, and in the merge menu, select one last time by distance, and you see how many vertices Blender welded for us. So you can see that's quite an important step to do when dealing with this kind of shattering process. I noticed now that all these are outside the active fractured object collection that I created, so let's M and move them back inside this collection. Okay, now we are ready to prepare our simulation. So I will create another collection, and this time I will call this passive object, because I don't want all of this to be involved in my simulation. So I switch to the wireframe, and pressing C, I get the circular selecting tool. I will select all these outer bigger shutters that we have here. I think I want all these, and all of them I want to move into this last collection that we made. Let's go back to solid view, and let's hide for one moment this passive collection. We have this little guy here. Let's move also him to the passive. Okay, let's hide again. And now I can go into the physics panel and click rigid body to set the properties for this object. And I can leave the default values as they are. So now this one is active rigid body. Pressing A, I will select all the rest, but the one will remain as an active object. And what you have to do now is to go to the object menu, rigid body, and select copy from active. And in a few moments, Blender will transfer these properties to all the others selected. And here we are. You see that now each one of my little shutters has become active rigid bodies. So if we now play our simulation, they start to fall down, and that's nice, but also it seems that they are having some issues here. You see, they are supposed to fall down nicely in the same starting position that they have. I don't want them to have this kind of behavior, and that's because probably they are too much near one to the other. So I want to go here under this sensitivity tab and turn on this collision margin option, and I want to reduce this number. Let's try 0.01, and once again we want to propagate this property to all the other elements. So under rigid body, let's copy from active. So let's try to play our simulation again, and it looks worst, really worst. So this means that in the first situation we only have few active elements that was too near, and so we try to reduce this collision margin. But because now we reduce this for all of them, and apparently it is not low enough, this number, they are all colliding and interacting from the first frame, and we don't want this, so we have to try to reduce even more. So let's try 0.001, and because now they all are sharing this property, I can simply right click and copy to selected to transfer this value to all the rest of my elements. So let's see if now it's working good. Yes, and it looks a little better. Okay, there are no small explosion. Okay, we have our basic simulation in place. Let's reduce our animation length to maybe 100 frames. And of course, we don't want to have all of them to fall down at the same time. So an easy way is to create some kind of support object. So let me create a new collection. We can call this helping object, and we can start adding a simple basic cube. Let's move this underneath all our elements. We want to be sure that they don't intersect, but let's try to bring them as close as possible. And I can, in the object properties, switch to wireframe visualization, and I also can uncheck the render option, because this kind of object are meant only to be helping the animation. I don't want them to be rendered. So what we can do now is to scale on the X and Y axis, and then let's move this until this corner is more or less in the center of my focus area here. And then I want to duplicate this and have, let's say, 4 of them. And the next step is to make these 4 cubes rigid bodies, passive rigid bodies, and because I will animate them, I want to check this animated option here. So let's go to Object, Rigid Body, and copy from Active. So now if I play the simulation, you see that it looks like nothing is happening, but they are actually falling down, but these 4 blocks that we just created are stopping them. So before I start animate these 4, I want to turn off the rigid body world so I can animate without being worried that the simulation will start and slow down my workstation here. And let's say that we want our crumbling down starts at frame 20. So we can select all our 4 passive objects, and with I want to insert a location keyframe. Let's open up our graph editor here. I want this movement to be quite slow, so let's go to frame 70. And then what I want to do is to bring them apart from the center, all of them. Something like this, in this kind of diagonal movement. And I want to insert a second location keyframe. Oops. And this one. So we have this simple animation that you can see. They will open this space and let all these objects to slowly fall down, attracted by the gravity of our simulation. So let's turn on again the rigid body world, and because our animation starts at frame 20, we can skip all these first 20 frames and set the simulation start frame at 20. Let's bring this down again and let's play our simulation. So let's see what we have. We can use this icon to disable all the wireframe objects, so we can focus only on the simulation. And already it looks way more interesting and dynamic. And remember that at any moment you may bring back your self-fracturing add-on and add more details to your simulation. So remember to get rid of the entire object, and then you want to select all these new shutters that has been created, enter edit mode for all of them, and then by distance merge all the vertices. You see more than 500 were welded together. Let's go back to object mode and move them into our active fractured object collection. And now you simply shift select one of the already active object, and in the rigid body menu you want to choose copy from active, and they are already added to our simulation. And let's say that we want to add some even more interesting and cinematic effect. We want to have some kind of shockwave at the beginning of our crumbling down effect, and we can do that simply adding another helping object that can be a simply UV sphere, for example, or probably I will use an icosphere that has less faces with the same icosphere. And also in this case I want to uncheck the render option and switch to wireframe visualization. I want to center this object here where the focus area is. Let's make it a little bit bigger, bring it down. Let's disable the rigid body world so I can animate this. And I know that all starts at 20, so let's say that at frame 10 I can insert a single keyframe location for the z-axis and 1, 2, 3, 4, 5, 6 frame after I want this to go up and push up all these elements. So insert another single keyframe, and then I want to bring this back down. So we have this moment here. Of course, we have to make this rigid body object, also this one passive and animated. So let's frame our floor here, and let's turn on our rigid body world once again. And remember also that we have the simulation start frame set at 20, and now it has to be set at 10. So let's see what we have. And you can see it's quite nice effect. We have this kind of bumping effect, and then all the floor that is crumbling down. Okay, so now let's say that we are satisfied and happy with this simulation. Let's bake this, so I can choose current cache to bake. So now I can scroll forward and backward without worrying about any kind of calculation issues. And the last step to do is to unhide the original floor object. Okay. And I want to find out the first simulated frame that seems to be, let me see, that is frame 12. Okay. So we want to have the entire floor object visible until frame 11. Let's insert a scale keyframe, and then the frame after we want to scale it down to 0. That means it will disappear from our scene. And in the same way, we want to do the opposite for all our chunks. So to easily do, let me hide the helping object collection, and then I want to select all the rigid body, active and passive. And I know that they have to be visible at this frame, at frame 12. So let's insert a scale keyframe. Oops. And here is a little tricky part in Blender. You have to know how to do this, because you see that now that I insert this keyframe for the scale value, you can see here in the graph editor all the shattered piece that has this scale keyframe at frame 12. But now when I go back at frame 11 and I scale down to 0, I only scale down the active element. So now if I insert the scale keyframe, only one is actually animated. So what I have to do now is to go here, right click and choose copy all to selected. You see that they all disappear, and now I can and insert another scale keyframe. So now you see they all share the same scale animation. So at frame 11 they are invisible, and at frame 12 they appear. So now if we unhide the entire object, switching between these two frames, we have the magic happening. So now we have our simulation in place. And one last thing, I promise, because this tutorial I know starts to be quite long. And the last thing that I want to show you is that you remember that we fix the topology for all these self-fractured pieces that we get. And now what we can do is to add a bevel modifier in order to add some nice rim light effect when we will render this. So I can tweak a little bit. Now I will leave the default value, but what I have to do is I can select all my shattered pieces with Ctrl L. I can copy the modifier to all the rest. You see that they're looking nicer. So that's how I realize my simulation scene that I use in few of my latest video using Blender. So that's it, guys. I really hope that you enjoyed this video and that you hopefully learned something useful. If you have any kind of question, don't hesitate to write down in the comment. And if you like this video, please leave a like and subscribe if you didn't do it yet to my channel. I also invite you to visit my Patreon page, where you can download this as many other Blender scenes that are associated with all my tutorials. Also, don't forget to visit my main YouTube channel SottoZen, where you can watch all my 3D animation and VFX work that I constantly upload. So once again, thanks so much for watching this, have a great day, and see you soon with another video. Ciao!